India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Kolkata and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich, and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the seafloor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya, first in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The 2 are gradually moving away from one another, which causes the formation of crevices within the Rift Valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into 2 continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the new Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries, after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hot spots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. You wake up, gasping for air, struggling to peel yourself from your bed. When you do manage to get your feet on the ground, it feels like they're glued down tight. You're twice as heavy. It feels like you're carrying another you on your shoulders all day long. Well, congratulations. You've woken up on an Earth where uncontrolled experiments with dark matter have doubled the force of gravity. Mass panic happens when over 8,000 aircraft fall as soon as the gravity spikes, crashing into buildings, forests, and oceans. And that's because airplanes suddenly lost the balance between the pull of gravity and the lift force necessary to keep them cruising. Pilots did attempt to save their planes, but GPS failed as satellites swiftly moved. After a month, humans begin to look more and more like chimps. Bones are getting thicker, and the immense force constantly pulling people down is squashing their spines, making everybody bend over. People start figuring out that walking ape-style on all fours helps with better balance and stability. And that becomes a big deal, since even tripping over a tiny rock could lead to a nasty fracture. Falls not only get more intense due to the extra forces on bones and joints, but they also happen faster. Gravity's pull doubles the acceleration force, increasing it from 32 feet per second to 64 feet per second. Your house is not a safe place anymore. Old buildings and bridges all over the world are now collapsing. Inside those still standing, residents get the scary feeling that the whole place is shaking, and cracks start showing up everywhere. It's dangerous to stay inside houses, as roofs are now twice their usual weight, and any rain or snow also feels twice as heavy. Car alarms are constantly going off because tree branches keep falling all over the place. Most trees simply can't bear the weight of gravity, and only strong and small plants survive, like cactuses and succulents. 6 months after the sudden change, supermarkets have a sinister vibe going on, with shelves nearly empty and people arguing over the last loaf of bread. You get frustrated to see that your favorite Japanese restaurant is now 5 times more expensive, And it's not just about salmon prices. It's rice that has become a rare luxury item, since the gravity boost has messed up the photosynthesis process, and the seeds are taking too long to grow. On the flip side, carrots are now cheaper than ever. They're sprouting and growing at lightning speed. People start eating so many carrots that human skin now has an orange glow from all that extra beta-carotene. Farmers are getting creative, using artificial supports to keep plants like tomatoes and corn on their feet. But even with all their efforts, it's hard to get a good harvest. Summer has arrived, and even your air conditioner can't relieve the unbearable heat. A sudden change in gravity disrupted Earth's orbit around the Sun, pushing it into a new, tighter elliptical path. Earth now passes much closer to the Sun than it used to, making your sunscreen simply surrender. The Moon's orbit has also had some dramatic changes, leading to more dangerous and extreme tide patterns. High tides are now higher and low tides are lower. This shift has also triggered widespread volcanic eruptions and earthquakes on an unprecedented scale. Earth's crust starts to rupture across vast areas, unleashing planet-wide lava flows so intense that living on Venus begins to sound like a pretty good idea. 5 years later, people notice that puppies are begging for food twice as much, but they are taking more time to grow. Breeds like beagles look thinner and their leg bones are getting heavier. Even insects, such as locusts, now have thicker hind legs to keep those jumps going. Sea creatures are being crushed by the much greater weight of the water around them. That's not a big deal for animals used to deep ocean pressures, like the anglerfish, but crabs and lobsters are really struggling since they live in shallow waters. Sloths and monkeys develop a stronger grip so they won't fall off trees. For carnivorous animals living in jungles or savannas, life is a real challenge because any animal the size of a wolf or bigger can't run without breaking a leg. Large predators like lionesses are starving because they can't move fast enough to catch their prey. Tall trees like palms and pines also go through evolutionary changes. They get beefier trunks and only grow about half as tall as usual. This way, water and nutrients can travel from the ground up to their leaves without struggling against gravity so badly. 10 years have passed since gravity increased. Airlines have finally made changes to prevent commercial flights from nosediving. The wings of airplanes are now longer. Pilots have learned to fly at altitudes twice as high, and flight speed has increased by 41%. To avoid people getting extremely nauseated and dizzy during takeoffs and landings, seats are now fully horizontal, like first-class bed-like setups, specially designed to minimize the nasty effects of gravity times 2. Flight attendants are trained to raise the seat at the passenger's feet after they pass out, so that blood can return to their head. The thing is, when gravity gets a power boost, it yanks your blood down to your feet and hands even more than usual, making your heart work extra hard to pump that blood around, especially to your head. 50 years have passed. Women in their 30s look like they are 60. Higher gravity decreases collagen synthesis, so even though they're still young, they're dealing with more wrinkles and fine lines, and their skin has already lost a big part of its elasticity. Wounds as small as a pimple pop or a paper cut also take much more time to heal. So people are excited about the creation of a Band-Aid made from fish skin from cod or tilapia that promotes local blood circulation and speeds up the healing process. People have also got used to wear exoskeletons made of titanium, which support and enhance the wearer's strength. This technology features cool joints at the places that copy humans' natural movements, giving people more flexibility and letting them move around more easily. Prototypes of personal flying devices start popping up after 100 years. The Gray Flyer is like a jetpack made of carbon nanotubes, making the structure strong without adding much weight. Instead of using fuel for propulsion, the device has these super-thin but high-tech solar panels. Investors are still not sure if humans could fly long distances with it, but the Gray Flyer definitely can help people tackle tasks that have become almost impossible, like climbing a mountain or grabbing something from the attic. Things at the gym are pretty different too. The anti-gravity treadmill is a favorite among fitness enthusiasts because it uses air pressure to lift users, reducing the discomfort of gravity while running. People can also lift weights in booths when the gravity settings are customized. When training with G-force set at 3 or 4 times the new normal, muscles get stronger, making double gravity seem more bearable. However, the maximum set is 4.6, otherwise bones might crack. Over 500 years have passed. Thanks to these amazing technological creations, humans can now handle and establish colonies in other parts of the universe. A popular choice for family vacations is Kepler 452b, a planet about 60% larger than Earth, orbiting in the habitable zone of a sun-like star. Kids especially like that place, as oceans have been discovered and hotels have been built near rocky beaches. On the other hand, traveling to places in the universe with lighter gravity is like going to an oasis of tranquility. So Mars and the Moon have become known for amazing yoga retreats. With their gravitational forces much weaker, people can breathe more easily there and move around with more freedom. Keep in mind that these trips are expensive, so you might want to start saving up now.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15-magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15-magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9-magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas Fault Line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe.
Rikat structure is a giant formation in the Sahara that looks exactly like a giant bullseye. It's so wide that you can see it from space. Even the CIA got interested in it. In 1965, they planned a flyover looking for geomagnetic anomalies. The findings are still classified. Perhaps the theories are true, and this place is truly the lost city of Atlantis. Now, Atlantis supposedly sank beneath the waves, but recent discoveries are pointing us in a different direction. This is an ancient story that goes far back in time, and Plato was the first to mention it. The place had loads of greenery and a curious structure: 3 concentric circles of land surrounding 2 circles of water. 2 key quotes from Plato's writing suggest that Atlantis might not have been a typical island in the middle of the ocean. Plus, Atlantis had a major influence from Africa and Europe, challenging the idea of it being in the Atlantic. It turns out that the Eye of the Sahara and Atlantis look alike. When astronauts saw the Eye of Sahara from above, they initially suspected a meteorite impact crater, but the rings of the structure matched the layout described of Atlantis. More importantly, the Sahara wasn't always a desert. It turned from a tropical region into a desert around 11,000 years ago. Researchers found evidence of a massive river called the Tamaracet that could have sustained a community. This river flowed toward the Rikat structure, aligning with Plato's description. The Trans-Saharan Seaway ran through the Sahara 50 to 100 million years ago. The sea allegedly destroyed Atlantis around 11,500 years ago, likely due to a rapid rise in sea level caused by the end of the Ice Age. NASA's worldview imagery shows patterns consistent with this theory. Those concentric rings might be a key to unlocking the secrets of our planet's evolution over millions of years. They're shaped by erosion on resilient rock layers, creating a spooky pattern of ridges and troughs. The central peak stands proud at 1,300 feet. The central part has undergone a significant erosion makeover, revealing a circular structure with a raised peak. Unlike impact craters, the Eye of the Sahara flaunts a striking balance and symmetry. Some say it results from rock uplift, sculpted by wind and water. Others think it's an ancient anticline, eroded to reveal its concentric glory. Then there's a salt diapir theory, suggesting that salt's buoyancy sculpted this beauty. Dating techniques have proved that it formed 541 to 252 million years ago, give or take a million or two. Ancient tools are scattered around the outer rings of the structure near riverbeds. Some older stone tools have also been spotted in the same areas. And still, even though some spear points from the Neolithic period have been found, there aren't many signs that people were living there back then. The area seems to have been used for short-term activities like hunting and making tools. There are other unearthly mysteries that haunt our world. One such enigma is in Norway: the ominous Hessdalen light phenomenon, also known as the Valley of Lights, leaves scientists confused. This valley is 10 miles wide. It's quite isolated, but a peculiar blue box sits high on the hillside, equipped with cameras scanning the valley. The unsettling saga began in the 1980s, when the night sky over Hessdalen erupted with burning fireballs, a recurring spectacle that sent shivers down the spines of those who witnessed it. This wasn't a fleeting occurrence, rather it became a regular thing. Terrified locals reported encounters with these unexplained luminous phenomena, some of which happened near their homes. Unease spread like wildfire. At its peak, there were about 20 sightings every week. The phenomenon made its way into newspapers, magazines, and media worldwide. Soon, people flocked to the valley, hoping to see the lights themselves. In 1984, experts joined the fray, armed with sophisticated instruments like magnetometers, radiometers, and other ometers. What they encountered was mind-bending, lights that defied explanation. Some moved at a leisurely pace, while others raced through the sky at an astonishing 19,000 miles per hour. People tried to explain these lights: airplanes, distant reflections, ball lightning, satellites, planets, meteors. But the speed and how these lights danced ruled out all those theories. We're slowly approaching another mysterious place. This is the greatest subglacial lake among Antarctica's 675 known lakes. It can easily hide unknown life forms. This lake is beneath the East Antarctic ice sheet. Dive about 2.5 miles under the ice, and there you'll see Lake Vostok, located at 1,600 feet below sea level. This lake is 155 miles long and 31 miles wide at its broadest point. With an average depth of 1,400 feet, it's also the world's sixth largest by volume. It's like an underwater city with lofty pillars and deep basins. The secret lake was discovered in 1993, yet it had been waiting to be found down there for over 2,000 years, collecting ancient secrets. In 2012, scientists drilled through the ice, creating the longest ice core ever. They pierced the ice all the way to the lake's surface. The year 2013 brought an unexpected twist when the tranquil waters erupted during the extraction of an ice core, mixing with drilling fluids. Then they got a pristine water sample in 2015. Some believe there might be previously unknown life forms down there, since it's a fossil water reserve that's been untouched for millions of years. That could be a lot like those speculated ice-covered oceans on moons like Europa and Enceladus. It all started with a theory in the 19th century, suggesting fresh water lurking under Antarctic ice sheets. Then, in 1955, seismic soundings hinted at a subglacial lake, and by the 90s, satellite data confirmed Lake Vostok's existence. Now, Lake Vostok isn't alone. In 2005, they found an island in the middle of the lake. Then, two smaller lakes joined the party. They suspect that a secret network of subglacial rivers might link these lakes. Now, very far away from Antarctica, in Venezuela, Catatumbo lightning presents a sinister light show at the junction of the Catatumbo River and Lake Maracaibo. This unsettling lightning phenomenon happens at about 140 to 160 nights a year, going on for 10 hours a day, and can flash up to 280 times in a single hour. The frequency of this lightning show changes with the seasons and from year to year. There was a break between January to March in 2010, causing a bit of worry that it might vanish forever. As the sun sets, winds from the east start picking up speed. The strong wind is called a nocturnal low-level jet, like what you see in the Great Plains of North America. These winds bring moisture, mostly from the Caribbean and the lake itself. This humid air hits high mountain ridges, causing thunderstorms to form over the mountains. Thanks to the ongoing wind situation, more thunderstorms appear as the night goes on. This pattern repeats itself, and is why this area has the highest annual lightning rate globally. The next place scientists cannot explain is in China. That is the Longyu Caves. They have lofty slanted roofs and sturdy pillars. The spot remained hidden for centuries. These human-made caverns, built around 2,000 years ago, decided to reveal themselves only in the 90s. Local farmers drained some ponds and unveiled 5 massive caverns. Further digging exposed an additional 19 smaller caves. They range from 60 to 110 feet in width and 26 to 50 feet in height. Archaeologists found historical relics from the reign of Emperor Zhuan of Han, dating back to over 2,000 years ago. Now, how did these caves survive for more than 2 millennia without falling apart? No ancient records explain the way they were crafted either. The walls show chisel marks, hinting at some layer-by-layer chiseling action, but the exact construction process is still a head-scratcher. Antarctica. It was once a green land full of dinosaurs, but now it's a frozen continent bigger than that of the US that doesn't belong to anyone. It isn't hard to find. Wherever you go, just go south until you get to the big icy thing at the south pole of our planet. It lies within the Antarctic Circle, and it's the largest single mass of ice on Earth. The continent is bigger than the US and even bigger than all of Europe. And still, Antarctica was officially discovered recently. Scientists hadn't known of its existence until 1820. After the discovery, it took another 2 decades to confirm it was a whole new continent, and a few more decades after that to decide on a name. In Antarctica, anti means the opposite. So Antarctica literally means the opposite of the Arctic. Now, even before scientists discovered the land, ancient Greeks already theorized that there must be a southern continent to balance out the Arctic in the north. Also, some scientists who studied Polynesian artwork and oral history believe that Polynesians found the continent over a millennia before the Europeans did. Anyways, today we all know of this icy land at the South Pole. Because of its location, there are just 2 seasons there, summer and winter, and both last 6 months. In summer, it's a bit warmer, and the continent exists in pure daylight. and in winter, it's dark all day long. 98% of Antarctica is ice. This continent alone stores 60% of the planet's fresh water. And yet, despite all those water reserves, Antarctica is the biggest desert in the world. By definition, a desert is an area with sparse vegetation and little snow or rain. Notice that plenty of sand isn't a necessary condition here, even though the continent does have some sand and even sand dunes. It also gets a lot of wind. Antarctica is the windiest continent on Earth, and wind speeds can reach 200 miles per hour. That's even faster than hurricane winds. The little snow the land gets never melts. It just builds up over time, for centuries and millennia. So there's a thick ice layer there. This makes Antarctica full of hidden secrets. There's a whole new world underneath its ice. For example, there are a lot of mountains on the continent that are like 9,000 feet tall. It's taller than 3 Burj Khalifas stacked on top of each other, if we must, and that's currently the tallest skyscraper in the world. But we don't see all those mountains because they're all hidden under the ice sheet that's almost 16,000 feet thick. There's also a lake down there, beneath over 11,000 feet of snow. The lake is called Lake Vostok, named after Vostok Research Station, under which it's located. Originally, it was just a hypothesis. Over a century ago, a scientist suggested that the huge pressure created by tons of ice could decrease the melting point of ice in the lowest layers of the ice sheet, creating liquid water, which could form a lake. He didn't prove his ideas in his lifetime, but others continued his work and confirmed that this theory was true. There's also a canyon in Antarctica, hidden underneath huge masses of snow too. It's deeper than the Grand Canyon we have in Arizona. There is a mountain range that divides the continent into 2 parts, East Antarctica and West Antarctica. The western part of the continent is experiencing higher temperatures and is starting to melt. If West Antarctica melts and releases its stored water, it will raise the average global sea level by about 16 feet. That will be enough for some cities all over the world to completely disappear. Perhaps the first to turn into a water world will be Thailand's capital, Bangkok, which is just 5 feet above sea level. Then it will be Amsterdam in the Netherlands, followed by Ho Chi Minh City in Vietnam, Cardiff in the UK, and New Orleans in the US. People do a lot of work in Antarctica now, residing there for many months at a time to study this mystery of a continent. Over the years, even a few children were born there. But it's not a country, and the land doesn't belong to anyone. It's governed by the Antarctic Treaty System, an agreement of peaceful research and collaboration that suspends all territorial claims. It was first signed by 12 nations, and now there are 59 supporters, half of whom have decision-making powers. The continent is occupied all year round by researchers from all over the world. There are about 5,000 people living there in summer and about 1,000 in winter. Yet no one is a permanent resident there. People come and go, and the scientists take turns spending time there. The average yearly temperature there is negative 30 degrees. But there was a time when Antarctica was about as warm as Melbourne, Australia is today. It was about 40 to 50 million years ago. I wasn't around then. But the continent had green forests and dinosaurs roaming its land, chilling in the sun in a 63-degree Fahrenheit environment. That was before penguins. In our age, it's so cold that you won't even find any trees or bushes in Antarctica, just the snow. The only plants that can thrive in such extreme temperatures are lichens, moss, and algae. People can't stand such freezing conditions for lengthy periods of time either, so the continent has never had any indigenous population. Well, that is, if we don't count penguins, seals, whales, and a few other types of birds that live there now. Antarctica's fauna is the scariest and least diverse on the planet because only a few organisms can withstand its harsh conditions and because non-natives aren't allowed to be brought there. So, if you decide to travel to Antarctica with your cat, well, you can't. Hey, I don't make the rules. But those few species that live on the South Pole totally own the place. There are no more than 5,000 people there and around 20 million penguins. They are a kind of settlers, though. Penguins' first ancestors lived in Australia and New Zealand. There are still a few penguin species there, including the smallest penguin on Earth that is just 1 foot tall. Still, most of the penguins migrated to Antarctica at some point, possibly because they were attracted by the greater food supply there. It's not the cold that made them like the land. It turns out, most penguins leave the continent when the summer ends. The only ones that stay there are male emperor penguins, and they do it to warm and protect eggs left by their mates. But where do all the other penguins go? At first it was a big mystery even to scientists, but then they attached some tiny location devices to the legs of a few of these animals and figured it out. Penguins go to live in the southern oceans while it's too cold in Antarctica. None of them go ashore for half a year until they get back to the continent. When they come back, it's when those eggs, left for male penguins to nurture, start hatching, and so penguin families can be together when it happens. Penguins eat different fish, and the ocean is full of those despite its cold temperature. In some areas, water can reach below freezing temperatures because it's salty. But fish don't freeze there because they have antifreeze proteins in their bodies. Then there are also about 1 million seals in Antarctica. They like fish too, and they can hold their breath underwater for 2 hours. They see way better underwater than in the bright light of the day, and they also use their whiskers to locate food. Their breathing holes in the ice can freeze while seals are away, and they must use their teeth to make a new one. Seals can even sleep underwater and then resurface occasionally to get some air without waking up. I can appreciate that. The largest volcanic region on Earth is not in Africa or Japan, but under the ice of Antarctica. Scientists found 138 volcanoes in its western part, and if they decide to go wild, you'll surely notice it. They could melt huge amounts of ice that will move into the ocean, raise its level, and make our planet uninhabitable for humans. But before you pack your things to fly away to another planet, hear me out. Only 2 of the Antarctic volcanoes are officially classified as active now, and it would take a whole series of eruptions decade after decade to seriously impact the whole world. Mount Erebus, one of the 2 Antarctic volcanoes currently in action, proudly bears the title of the world's southernmost active one. It has been continuously erupting since at least 1972. It emits plumes of gas and steam and sometimes even spews out rocks, and scientists call it Strombolian eruptions. One of the coolest features is a lava lake in one of its summit craters, with molten material on the surface. Such lakes are rather rare because they need certain conditions to make sure the surface never freezes over. The second active volcano is Deception Island, a horseshoe-shaped landmass. It is the caldera of an active volcano that last erupted over 50 years ago. Scientists who monitor it say it shouldn't go wild anytime soon. Antarctica also has plenty of fumaroles. Those are volcanic vents that release gases and vapors into the air. In the right conditions, they can spew out enough stuff to build fumarolic ice towers up to 10 feet tall. Scientists keep an eye on the Antarctic volcanoes with seismometers that detect when the Earth starts trembling from volcanic activity. Sometimes they also use more complicated tech, but it's all really challenging because of how far away this polar region is and how tricky it is to get there. That's why no one can predict when one of the continent's volcanoes that are now sleeping might erupt. We can guess what this waking up would look like if we analyze the events from nearly 20,000 years ago. So, shall we? One of Antarctica's sleeping volcanoes, Mount Takahe, had a series of eruptions and spewed out a good amount of halogens rich in ozone back then. Some scientists say these events warmed up the southern hemisphere. Glaciers started to melt and help finish the last ice age. For these events to repeat, we'd need a series of eruptions with substances rich in halogens from one or more volcanoes that are now above the ice. It's an unlikely scenario, but since it already happened in the past, it's not completely impossible. As for volcanoes hiding under a thick layer of ice, it looks like their gases would hardly make it to the atmosphere, but they would be strong enough to melt huge caverns in the base of the ice and produce a serious amount of meltwater. The West Antarctic ice sheet is wet and not frozen to its bed, so this meltwater would work as a lubricant and set the overlying ice into motion soon. The volume of water that even a large volcano would generate in this way is nothing compared to the volume of ice beneath it. So, a single eruption wouldn't make a difference. but several volcanoes erupting close to or beneath any of the western Antarctica's big ice streams would. Those ice streams are rivers of ice that take most of the frozen water in Antarctica into the ocean. If they change their speed and bring unusual amounts of water into the ocean, its level will rise. As the ice would get thinner and thinner, there would be more and more new eruptions. Scientists call it a runaway effect. Something like that happened in Iceland. The number of volcanic eruptions went up when glaciers started to recede at the end of the last ice age. So, it looks like, for massive changes, several powerful volcanoes above the ice with gases full of halogens need to get active within a few decades of each other and stay strong over many tens to hundreds of years. Antarctica stores around 80% of all the fresh water in the world, and if they melted all of it, global sea levels would rise by almost 200 feet. And then we'd have to look for a new planet to live on. But this again is an unlikely scenario. It's more likely that the eruptions under the ice will lubricate ice streams and seep water into the ocean. But it wouldn't be the end of the world. A super strong, super angry supervolcano could do it though, and it has already happened in the past. Over 200 million years ago, the world went through a major makeover with not one, not two, but 4 massive volcanic eruptions in huge pulses. The supervolcano called Camp had been erupting over and over for 600,000 years. It all happened in Wrangell, a large chunk of land that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. And it wasn't the lava or the volcanic ash that ruined the environment. The eruption made carbon levels skyrocket. The planet would never be the same again. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in Asia to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels. It made the atmosphere toasty, and the rain poured down. So the bad news is, another eruption like this could happen. The supervolcano beneath Yellowstone National Park has been sleeping for nearly 70,000 years. But if it wakes up, it would be many times more catastrophic than the eruption of Mount St. Helens in 1980. It's considered the most disastrous volcanic eruption in U.S. history. It followed 2 months of earthquakes and injection of magma below the volcano that weakened and destroyed the entire north face of the mountain. The eruption column went 80,000 feet into the atmosphere and spread ash over 11 U.S. states and several Canadian provinces. The last Yellowstone eruption was 1,000 times greater than that. The ground above Yellowstone sits on a hot spot made of molten and semi-molten rock called magma. This magma stuff flows into a chamber beneath the park, about 4 to 6 miles down, making the ground puff up like a balloon. But then, as it cools down, the ground goes back to its usual state. Volcano watchers have been keeping an eye on this for a century. They noticed the ground lift up about 10 inches around 20 years ago, but since 2010, it's been going back down. The experts say we have no big eruptions on the horizon, so doomsday isn't coming anytime soon. But there's some underground activity going on lately which keeps us interested. Since humans haven't been around to witness every little thing Yellowstone does, it's kind of tough to say for sure what's brewing down there. Yellowstone has had some epic eruptions within the last couple million years. They happen like clockwork, with gaps of 600,000 to 800,000 years between them. The last big one was around 640,000 years ago, and it basically reshaped the entire landscape, spreading ash and debris as far as Louisiana. You can still see the aftermath of the last big eruption in the Yellowstone caldera today. Experts say a massive eruption like the last one is an unlikely scenario. We're more likely to see eruptions of steam and hot water or lava flows. When and with what force it will wake up remains a mystery to scientists. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm. Or at least, we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic, smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. You step on the surface of the moon. It's unusual. You definitely feel lighter here, and it's easier to walk. You decide to check out that obsessive idea of yours, jump on Earth's natural satellite. And even despite your bulky spacesuit, you literally fly up into the air. Woohoo! Anyway, you continue your walk on the surface of the moon when you feel something strange. The ground under your feet is it shaking? It feels as if an earthquake has just started on the moon. But that's simply impossible. Or is it? Surprisingly, your gut feeling hasn't let you down this time. Moonquakes do exist. In fact, there are 4 types of moonquakes that are strong enough to be detected from a large distance. There are deep moonquakes occurring more than 430 miles below the surface. Then there are meteoroid impacts. Thermoquakes occur when the frigid lunar crust expands. It happens when the morning sun illuminates the satellite after a 2-week-long deep freeze lunar night. And there are also shallow moonquakes. They're the only ones that are similar to earthquakes on our planet. Shallow moonquakes happen 12 to 19 miles below the surface, and they're the most powerful and dangerous. Between 1972 and 1977, the Apollo seismic network recorded 28 such moonquakes, and some of them measured more than 5 on the Richter scale. On Earth, such an earthquake is strong enough to crack plaster and move heavy furniture. Plus, shallow moonquakes are very long-lasting in compared to earthquakes. Once they get going, they can continue for up to 10 minutes. As for the average earthquake, it typically continues for 10 to 30 seconds. Scientists are still not sure what causes shallow moonquakes, and even where exactly they occur. One of the theories is that moonquakes happen at the rims of large, relatively young craters that probably slump from time to time. Interestingly, the Moon and Earth aren't the only places where earthquakes occur. No, scientists time frame of when an earthquake might occur. Earthquakes can be triggered by volcanic eruptions or, let's say, meteor impacts, but most of them are caused by the movements of our planet's tectonic plates. Earth's surface consists of 15 to 20 constantly moving tectonic plates. Pressure increases when they shift, and this can make the crust of our planet break. San Francisco is moving toward Los Angeles right at this moment. The speed of its movement is about 2 inches per year. That's as fast as your fingernails grow. It's happening because the two sides of the San Andreas Fault, which is the continental fault extending 750 miles through California, are slipping past each other. So, in several million years, Los Angeles and San Francisco will be neighbors. Lakes, ponds, and canals become slightly warmer and start to stink before an earthquake. It happens because gases get released when tectonic plates shift. Most animals feel these signs and change their behavior. For example, scientists noted toads completely disappearing before an earthquake in Italy in 2009. But as soon as the natural disaster was over, they returned. Even after an earthquake is over, you might still see water sloshing around in your swimming pool. There's no need to worry. This is a phenomenon called a seiche. The water can keep sloshing around for hours after the earthquake is over. For example, the pool at the University of Arizona lost some water from a seiche caused by an earthquake in Mexico that occurred 1,200 miles away. On February 27, 2010, a massive earthquake started in Chile. It measured 8.8 on the Richter scale. As a result, Earth's crust in that region was ripped so dramatically that a city called Concepcion moved 10 feet to the west. Another earthquake resulted in the tallest mountain in the world, Everest, shrinking by 1 inch. It happened in 2015 when a magnitude 7.5 earthquake caused several Himalayan mountains to decrease in size. The Japanese used to believe that earthquakes were caused by namazu, a giant catfish that lives submerged in the mud under the Japanese islands. The fish would thrash about, causing seismic activity. As for the ancient Greeks, they were sure that a powerful sea deity, Poseidon, produced earthquakes by hitting his trident against the earth when he was angry. According to Hindu mythology, 8 elephants hold Earth in place. They are, in turn, balanced on the back of a ginormous turtle, standing on the coils of an even larger snake. And every time any of these animals moves, an earthquake occurs.
Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that, a fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1. Insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2. Heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3. Underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4. Salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5. Building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and negative 200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars, Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between ½ an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangaea, Pangaea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangaea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangaea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangaea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangaea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away. The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds. An earthquake in Indonesia began in 1829 and lasted a mighty 32 years. It reached its climax in 1861 and hit a magnitude of around 8.5. It was caused by the tectonic plates below the island slowly clashing against each other. Researchers discovered that the quake had been building for some time after analyzing the coral in the area. They found it was being periodically exposed to the open air. That was caused by the gradual earthquake moving the land up and down. Scientists call these decades-long silent earthquakes slow slip events. A single lightning bolt can warm the air to around 54,000 degrees Fahrenheit. The heat makes the air expand quickly, creating a shock wave or boom, which we know to be thunder. There are close to 3 trillion trees on Earth. That translates to roughly around 422 trees for every person. Before humans, the number was nearer to 6 trillion. Almost 70% of the Earth's surface is covered by water, which on average is around 2.5 miles deep. 97% of Earth's volcanoes lie underwater, as well as the mid-ocean ridge, a massive mountain range that is over 40,000 miles long. Humans have mined around 190,000 tons of gold from the planet. Experts predict there is around 20% still left to be mined, but this figure is constantly changing. The world's largest active volcano is in Hawaii. Called Mauna Loa, it's over 2.5 miles above sea level. Given that most of it is underwater, the volcano's summit is a staggering 11 miles from its base. That's the same length as over 160 football fields. The highest ever recorded temperature on Earth was a sweltering 136 degrees Fahrenheit. It was recorded in El Azizia, or modern-day Libya, on September 13, 1922. The lowest temperature was a chilling minus 129 degrees Fahrenheit, recorded at Russia's Vostok station in 1983. Earth is the 5th largest planet in the solar system, behind Jupiter, Saturn, Uranus, and Neptune. It has a circumference of roughly 25,000 miles, and it would take the average person around 8,300 hours to walk around the face of the Earth. The separation between Earth's land masses would make such a trek almost impossible, though. It takes 365.25 days for the Earth to orbit the Sun. Because our calendar years only have 365 days, we add an extra leap day every 4 years to make up for the difference. Russia is the largest country on the planet, with a total area of about 6.5 million square miles. It encompasses more than 1/8 of the Earth's inhabited land area, but still has a relatively small population given its size. Earth is the only planet with one moon. Mercury and Venus have no moons, while every other planet has 2 or more. Earth is over 4 billion years old. Scientists calculate this by looking at the planet's oldest rocks, as well as meteorites that have crash-landed. They used meteorites as they were formed at the same time as Earth, when the solar system was forming. The ground we walk on is basically recycled. The planet's rock cycle turns igneous rocks to sedimentary ones, then transforms those into metamorphic rocks, and back again. Like Earth, our moon also experiences earthquakes. They're less common and intense than the ones we have, and are caused by tidal stresses. A tidal stress is basically the relationship between the gravitational pull of the moon on the Earth and that of the Earth on the moon. Despite being the 5th largest continent, Antarctica holds 70% of the planet's fresh water and about 90% of its ice. Bangkok is the most visited city in the world, boasting 23 million visitors in 2019 alone. Paris, London, Dubai, and Singapore make up the other cities in the top 5. The lowest layer of Earth's atmosphere is called the troposphere and is the reason we have weather. Sunlight heats the planet's surface, which causes warm air to rise up to the troposphere. This air then expands and cools as the air pressure decreases and sinks down, where it is then warmed by the Earth again. Coral reefs are the largest living structures on the planet, with some even being visible from space. Coral reefs hold the most species per area of any of Earth's ecosystems, even more than rainforests. Earth got its name around 1,000 years ago, and it comes from the German word meaning the ground. but there's no evidence to show who actually named it. Of all the planets, Earth is also the only one which is not named after a Greek or Roman deity. The deepest point of the ocean is the Mariana Trench. It's a whopping 7 miles below sea level. Coastlines cover about 20% of U.S. land, but are home to more than 50% of the U.S. population. The Earth isn't actually a sphere. It's more like a squished ball that bulges at the equator. The bulge is caused by the force of the Earth spinning, which makes the north and south poles slightly flat. The Earth spins on its axis, which is basically an imaginary straight line. Earth has seasons because the axis is tilted, causing the sun's rays to hit different parts of the planet more directly, depending on the time of year. If the sun was as tall as a standard door, the Earth would be around the size of a nickel. The Earth's rate of rotation is gradually decreasing. It's happening so slowly that it would take as much as 140 million years for the length of a day to increase to 25 hours.
Get equipped for any season with brand new Brightside merch. Click the link and grab your print.
The biggest animal on Earth is the Antarctic blue whale. It can reach lengths of 100 feet and weigh up to 400,000 pounds, which is around the same as 33 elephants. The temperature at the center of the Earth is around the same as the surface of the Sun, at almost 10,000 degrees Fahrenheit. Earth is around 10,000 times older than humans. Earth is around 4.5 billion years old, whereas humans have been around for, at most, 450,000 years. There are around 34,000 known species of fish. The actual number is way higher though, as a whopping 95% of our oceans still haven't been explored. America's Route 66 is longer than the journey to the Earth's core. The distance to the core is roughly 2,000 miles. Route 66 is almost 2,500 miles. The Earth is made up of 3 main components: the crust, the mantle, and the core, which is divided into the outer core and the inner core. Scientists have estimated that there are around 8.7 million species on the planet. Out of this, between 1 to 2 million of these species are animals. But roughly 86% of land species and 91% of fish have yet to be discovered by humans. Ancient astronomers used to think that the Earth was the center of the universe. For 2,000 years, they believed the Earth to be static, while other bodies traveled in orbit around us. In 1543, Copernicus published his sun-centered model of the solar system. Earth is the densest planet in the solar system. The density varies across its different crusts, but the planet's average density is just over 3 ounces per cubic inch. Mount Everest is the highest point on the planet. Its peak is the highest altitude above sea level at around 5.5 miles. Each year, 1 septillion crystals of snow fall on Earth. That's a trillion snowflakes. Snow covers about 31% of Earth's land area each year. Of Earth's water, only around 3% is fresh water. The other 97% is salted. Of that 3%, about 2% is frozen in ice and glaciers. So, less than 1% of the planet's fresh water is actually in lakes, rivers, and underground. The world's largest inland body of water, or lake to us normal people, is the Caspian Sea. It has an area of 140,000 miles squared. The world's deepest lake is Lake Baikal in Russia and is 5,300 feet deep. Earth's atmosphere is roughly 78% nitrogen and 21% oxygen, with small amounts of water vapor, carbon dioxide, and other gases. No other planet is believed to have this much oxygen, which explains why Earth is the only planet where life has been discovered so far. Apart from the Moon, there are 2 asteroids in co-orbital orbits with Earth, sometimes called Earth's second moon. 3753 Cruithne is an asteroid that looks like it's following the Earth in orbit, but it's actually following its own path around the Sun. 2002 AA29 is another asteroid which makes a horseshoe orbit around the Earth that draws it close to the planet every 95 years.
If you live in a hot spot for earthquakes, like I do, you may have had these familiar shaking feelings. The ground trembling underneath you, pictures rattling on the walls, your neighbor's dog yapping across the yard. An earthquake is basically tectonic plates moving and grinding against each other. Rub your hands together really fast right now. Things heating up? That's energy. When these plates' energy get released, you and your neighbor's dog feel it on land. Yes, we're all surfing on giant pieces of land floating on hot liquid rock. You're surfing right now while watching this video. Sometimes one slides under another, like reaching in between the couch cushions for that remote that slipped down there. If you're wearing long sleeves, they get rolled up on your arm like a snake shedding its skin. When plate tectonics do this, mountains form. But let's zoom out from your bedroom. Even further. Keep going. There. Earth, the third planet from the Sun, covered in mountains, canyons, and those familiar continents with oceans stretching between and all around them. But our planet used to have just one single supercontinent, Pangaea, where all the land masses were hugging each other and enjoying the sweet life surrounded by one massive superocean. Africa and Australia were neighbors. The Americas and Asia popped up for a howdy neighbor. But fast forward about 300 million years, and here we are. And there you are, hanging 10 on molten rock as the ground beneath you forms mountains, ridges, volcanoes, and earthquakes. Sounds hardcore, but you don't feel like you're moving, do you? You also don't feel like your body is going highway speeds when you ride in a car. That's physics, and it's a funny thing. Right now, the plate under you is only moving a couple of inches a year, up to 4 when things get super speedy. Per day, that comes to half the width of a strand of hair. So let's speed things up a bit, say 300 feet a day. And me too.
You're sitting in your room enjoying a delicious cup of hot cocoa, scrolling the feed and watching some videos. As you set the mug on the nightstand, you begin to feel dizzy, like the room is spinning. You check your drink and see the liquid inside is swaying like crazy. Uh-oh, now you're swaying. You manage to get up but can't keep your balance. Everything topples over like a tornado in the room. You duck underneath your bed and cover your head. There's a power outage, and now you can't see anything.
There are 2 things to keep in mind when it comes to earthquakes: magnitude and intensity. Magnitude is the size of the quake. It's just one constant number. Intensity is how much shaking it causes. That number can be different depending on where you're measuring from. The most powerful earthquake ever was in Chile in 1960. Its magnitude measured 9.5 on the Richter scale. Above 7 is considered severe. The quake caused tsunamis all the way to Japan, Hawaii, the Philippines, and even New Zealand. The damage cost millions of dollars in repairs.
In the dark, you can still feel the ground shaking below you. And since the crust cut across 300 feet today, the ground rips open. The landscape where you used to bike around is now sprouting deep earth rocks and minerals. The buildings all around begin to collapse, but luckily, you manage to sneak off and escape into an open space. There isn't any service on your phone either. The cell towers toppled over during the quake, but the ground is still shaking. And with the plates moving so fast, the Earth's interior begins to show its true colors. And that color is red, red for red hot. You can see the mantle at this point. The Earth, like an onion, is revealing its layers. With magma flowing right in front of you, you'd think you're in a disaster movie. Suddenly, you get a whiff of salty sea air, and now you're standing on the beach. But wait a minute, you don't live by the coast. If an earthquake's strength is measured by magnitude and intensity, this one's a doozy. It probably originated out in the ocean and stretched all the way inland where you are. It caused a tidal wave so big, the coast just came to your landlocked town. Waves of ocean water are gathering near the edges of the city. Farms and rivers are all gone with a single tidal wave. The land that was good for agriculture is no more. And as the ground below you keeps on cutting, it lets in some ocean water between the gaps. It collides with the magma that's rising. Steam shoots up from the ground, and the Earth looks like a giant tea kettle. With the power out and no cell signals, there's no way of communicating with anyone. And that's just the thing with earthquakes. They can show up with hardly any warning.
Unlike earthquakes, tornadoes, and typhoons, with those, we can predict their path and intensity. We can prepare. Even volcanic eruptions give people enough time to evacuate and reach safe ground. But earthquakes are just in a league of their own.
And with all the buildings collapsing around you, you'd be seeing a smokescreen of dust and debris. The air would be unbreathable. Better grab a gas mask. Off in the distance are the mountains you've always enjoyed. You trekked along the trails every other weekend and had some fantastic camping trips along the river. But the earthquake drags across the center of the mountain and creates enough pressure to cut it. Trees start falling over. The mountain becomes a pile of rock and dust. It's not over yet. The shaking ground makes large pieces of land and rock slide down and head towards the town. Some landslides are so massive, they're enough to wipe out entire villages in remote areas. Many come after heavy rain, others come completely unexpected. With the ground opening beneath you, many of the objects on land get swallowed into the pit. Cars, trees, buildings, statues, you name it. You're able to find safe ground, but you can't really know if it's all that safe. All this is happening in your town and places across the globe. But it's about to get even more global.
Plate tectonics are crucial for life on Earth. One of their main duties in a thankless job was maintaining the planet's comfortable, livable temperature. Without landmasses floating around on a layer of liquid rock, there'd be no life on the liveliest planet we know so far. A couple of billion years ago, Earth was just a little ice ball. This was because the sun, much younger back then, was colder than it is today. You'd think the oceans would be frozen and good enough to skate from the Atlantic to the Pacific, but they weren't. And it's all because scientists believe the shifting plates underneath kept the oceans warm and cozy. They did that by creating underwater volcanoes. Besides lava and many gases, they spewed carbon dioxide into the atmosphere, which trapped the heat on Earth. As the sun gradually got hotter, rainfall was able to drag the carbon dioxide back to the ground and into the mantle. And this cycle was able to help the Earth maintain its temperature to host us. Gee, how thoughtful. Earth is so unique because of these plate tectonics. No other planet in the solar system can brag of the same, except for Jupiter's frozen moon Europa. It's shown evidence of moving plate tectonics within the core. And even though Venus and Mars have hot interiors, there hasn't been any sign of such activity.
As the ground continues to cut across the land, everything in sight has now descended underground. If the plates were to move 300 feet a day for a year, the entire planet's landscape would go through a total makeover. A bad one. Life as we know would cease to exist, except for maybe microscopic bacteria and a few insects that can survive such harsh conditions. The polar ice caps wouldn't hold any more ice, and volcanoes would continuously be erupting. The planet would just end up looking like a hot fireball of destruction, and maybe even burn up entirely.
Luckily, this is purely a hypothetical thought experiment. So, sit back, relax, and don't worry about the ground moving under your feet. It's taking its sweet time at a safe pace.
Woohoo!
Floods, tornadoes, tsunamis, hurricanes, yikes. All these natural disasters can get extremely dangerous, but we're kind of familiar with them. But how about a natural disaster that has never happened before, but could occur any moment now? It might be a super eruption. That's what happens when a supervolcano erupts. You might know that Yellowstone Park is located on top of a supervolcano. The last massive eruption there happened about 664,000 years ago, and the one before that, approximately 1.3 million years ago. If we do the math, we'll understand that the next eruption might be due anytime soon. There's no strong evidence that the supervolcano is waking up or preparing for an eruption, but what would it be like if it did happen? Months before the eruption, small-scale earthquakes would become more frequent and more powerful in the area. Not long before the eruption, the growing pressure would push up the ground over the volcano, creating a dome. Narrow cracks would open along the edges of this dome. The magma would then start rising toward the surface, and then the eruption would kick off. A massive column of lava and ash would shoot up into the air to a height of over 16 miles. The volcano would keep pumping ash for days on end. The air in that area would heat up to 570 degrees Fahrenheit. For all living creatures, ash fallout would be one of the most dangerous consequences of the eruption. Buildings and trees would start collapsing under the weight of this dense substance. It would only take a couple of days for a 10-foot layer of ash to cover the territory of about 50 miles around the center of the eruption. After the ash got into the stratosphere, the temperatures all over the world would start to drop. The eruption would also be rich in sulfur, and this element is an effective sun blocker. That's why it would soon get so cold that there would be no summer in the whole world for the next several years. The monsoon seasons would change. It would be hard for animals to find food and clean water. Well now, how about a gamma ray burst? You don't stumble across this kind of radiation in your everyday life. A gamma ray burst occurs when two neutron stars collide. The collapse of a massive star can produce it too. Gamma rays could present a serious danger to Earth. If a gamma ray burst happened close to our home planet, it could rip our ozone layer away. After that, we would be left unprotected from the sun's ultraviolet radiation. Plus, gamma rays could also produce ground ozone. This kind of ozone could seep into the ocean since it's water-soluble, and that would lead to a mass extinction of marine life. Plants wouldn't survive this disaster either. Now, come to think of it, giant sinkholes could swallow entire communities. One of such sinkholes opened up in the city of New York. It pulled a parked van into the earth. That happened in the summer of 2022. And it wasn't the only sinkhole to appear in that area. Local inhabitants reported about 4,000 sinkholes all over the city. This kind of problem is also very common in Florida, and it's much more serious than it may sound. Sinkholes open all of a sudden, pulling down everything and everyone that happens to be nearby. Sinkholes appear all over the world, which makes them a global problem. They're totally unpredictable and form without warning. Luckily, experts know what causes them. In some areas, there are vast areas of groundwater. But during droughts, this water dries up. This creates large empty caverns, and after heavy rains, the surface over such a cavern can collapse, creating a sinkhole within minutes. Now, what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest one to us is 1,500 light-years away. Nothing to worry about, right? Until you find out about wandering black holes. Now, things get definitely way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2012, 13 wandering black holes were spotted not so far away from our planet. But worry not. Not far away, in space terms, means around 1 billion light-years away. So we've got some time left. Plus, the possibility of such a disaster is very, very low. Another natural disaster we haven't experienced yet is a mega flood. It's never happened before, but the changes in climate do make for a risky potential. It could start, let's say, in California. This state experienced some really bad flooding in the past. One of such floods stretched up to 60 miles across and 300 miles long. If a similar disaster happened these days, it would cause $1 trillion worth of damage. It would also uproot millions of people. Now let's talk about a hypercane. Judging from the name, this natural disaster might get extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or because of a massive volcanic eruption. In any case, these conditions could create a hurricane that would stretch way beyond the lower stratosphere. And as you may guess, regular hurricanes don't do that. The hypercane speed would reach 500 miles per hour. The pressure inside would be low enough not to let the hypercane to wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It could damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Now, this disaster did happen before. About 66 million years ago. I bet you know what I'm hinting at. Yep, that very meteor that supposedly wiped out dinosaurs off the face of the Earth. This 7-mile-wide space visitor was traveling at 67,000 miles per hour. As a result of the collision, 75% of all life on the planet disappeared, and winter reigned on Earth for 18 months. Want to know a secret? Meteors strike Earth all the time. Even more of them barely miss our planet. But it's also very hard to predict meteor strikes. Scientists miss a lot of them until they just nearly miss us. That's why experts are working on an early warning system that could prevent disasters. It could make meteor impacts less catastrophic, or at least allow people time to evacuate. It could also be our very own sun that would be responsible for another natural disaster. I'm talking about a massive solar flare. On the scale of damage to society, few catastrophes can compare to this event. It wouldn't destroy buildings like a tsunami or an earthquake. Neither would it end lives in the same way a supervolcano or meteor would. But it would cripple our entire way of life by destroying the whole electronic infrastructure of Earth. The cost of this disaster would reach trillions of dollars. It'd cause other infrastructures to fail. Communication, medicine, transportation, banking systems, those would tumble like dominoes, and it would be incredibly hard to recover them. Earth would be left without electricity for years. There would be no electric light, no computers, no phones. Water supply systems would be out of order. There would be no food in supermarkets. There would be no electricity, and people wouldn't be able to reboot the already broken power grids. In 1859, people all over the world woke up in the middle of the night. It was as light as during the day. The skies were illuminated with auroras, red, green, purple. They appeared even in the regions where no one had seen them before, like the Bahamas, Jamaica, or Hawaii. Telegraphs got electrically charged, even though they were disconnected. In many areas, fires started. That was when technology barely existed. But imagine the avalanche of problems a solar flare could cause today.